Now I'm going to begin the process of installing the outer ring around the inner ring. This inner ring, which earlier I showed having pins driven into it to stabilize it, has been mounted on the lathe and a channel cut in with 30-degree bevels for the wheels to lock the inner and outers together. In addition, the sprockets have been chamfered just a little bit so that the chain will fit better. That was also done on the lathe. I'm not quite sure how this is going to go together. The whole point here is to assemble a number of wheels and then slide the wheels into the slot, the chamfered slot. And I don't know exactly how many wheels I can get on before it won't be able to slide on. Ideally, 4 wheels is going to be less than 90 degrees, so it's likely that 4 wheels should work just fine. Put the wheels in, the pins in, and then put the retainers in. For now, all I'm doing is putting a temporary screw in. There has to be some caps manufactured that I haven't made yet. I just want to try and fit these to see if there are any major problems. I'll check here as soon as I get so here are 4 wheels. I'll put them on and it slides really nicely. Flip the assembly over and we're going to add 2 more wheels on one side and check it again. Pins, Delrin wheels, cap, there we go. Six should work. Oh, how about that? Yeah. Okay. If I try and put it on directly, it's too much. But if I sort of slide it down and over, it's going to be together. So at this point, all the rest of the assembly is going to have to be done in situ. We'll see how. Imagine that means that I certainly will not be able to put the pin in and then slide the wheel over it. That's not going to work. But if I slide the wheel in and put the pin in afterwards, that should work. Unless I throw it on the ground. These are the lessons you learn when you first try and assemble a robot. All right. There we go. All right. Now at this point, it's kind of locked together, and I have to flip it over to do the next set of wheels. I remember this design is intended to fit somewhat loosely. I imagine if I made it too tight, that this would be a nightmare to install. But there you can still see there's some slop here. Now this piece goes here. So that means when I'm looking for the connector, this is going to be this limited piece here. It's not as large. It has this end that's beveled to match up with that hole. I'm not really sure if this was a smart idea to put this piece in last. There we go. And we'll try and turn this around and put these two wheels in to match up with this. That was easy. Go. Let's see how difficult this is going to be. As things get tighter, it's a little more difficult to line everything up. There we go. And it appears as if I'm running a little bit short on screws. And there's a good 10 thousandths of clearance between the screw and the sprocket. plenty of room, just like it was designed. Okay, so temporarily, let me see if I can use some of these 1-inch screws just to get it together. See if they're long enough. And they are. Not that I'd want to use them. Now you've got one last little section here that needs to be pulled together. And that's this last shorter piece. 3 little wheels left. 1. Oops. Wheel first. 2. And the last one. There we go. Now, I was gonna guess getting these 3 to go in together at the same time is gonna be a big pain in the butt. But that's what fast forward is. Whoa. Hey, how about that? All right. This represents sort of the minimum number of screws to hold this together. In terms of assembled play, there's a good 1/16 of an inch up and down. Probably only maybe 30 thousandths left and right. But I can tell you, that feels really good. And there's a lot of material there holding it in place. So I'm gonna drop in a few more screws, make it a little sturdier, and then we're gonna move on. It's coming together.